Alright friends, this is the solution for the paper for the month of April 2025, and I have tried to come up with a solution for all the theoretical questions that have been asked. Numerical is a separate section altogether, and here let's go through these questions which have been detailedly answered here, and I would like you to subscribe to the channel, share it with all the friends who are giving the ETO exams, which can help them prepare for their exams at the earliest. This is a time saving exercise here, so you go through the last 1 year question papers, and try to solve them, and hope the questions get repeated. Of course, there will be one or two questions which will be new, but by and large there will be repetitions. So let's go to the questions. The first question here, the Q1, is explain the matching of an induction motor to a pump required for a main circulating duty pump with the aid of a pump characteristic and torque diagram. So let us take an example of the pump that keeps on circulating, that is the boiler feed water circulating pump. Also, the main engine fuel oil, generator fuel oil supply circulating pumps are also continuously circulating, but they are positive displacement. But the boiler feed water pump is definitely a circulating pump. So we are discussing the matching of the induction motor to the pump here, right? So coming to the context, okay, even your the main engine jacket water pump, right? Usually it is running all the time, or also your vacuum condenser pumps, they are also running all the time, so they require continuous and reliable flow for cooling of water. Induction motor, a common choice on ship because of the robustness and the simple construction, suitable for constant speed duties. Most of our duties are constant speed, 60 hertz, so we require an induction motor. The construction is very simple and robust. Goal is to choose a motor that can start, accelerate and drive the pump under all expected loads condition without stalling or overloading. So coming to the pump characteristic. Mm, Before we go to this theory part, there is a diagram that I would like you to have a look at. It's here, right? So here you will see the matching of the induction motor to the pump, that is the torque speed characteristic. So in the blue line you will be seeing the pump torque speed curve, and in the orange line it is the motor's torque speed curve. So they intersect at a particular point, right? Here the torque speed diagram shows the pump torque curve and the motor torque curve with the rated operating point marked. So the operating point is marked here, that is somewhere here on top, right? And this visually directs support to the written theory that we'll be putting forward. So for example, uh, coming to the pump characteristic, a centrifugal pump, as we all know, there is a HQ curve. The head decreases as the flow increases, and the power versus flow curve starts low at shutoff and rises with flow. Like initially, any centrifugal pump, the common practice is to shut the discharge valve, start the pump, and then slowly open it. So initial current will be low, right? When the system stabilizes, then you slightly open the valve of the discharge, and there is a stability in the current. Efficiency versus flow curve. Peak efficiency at a certain flow rate, best efficiency point, the BEP, whatever you can call it. For a centrifugal pump, the torque required is proportional to the square of speed and to the generated head. At zero flow, the torque is always low. That is why you shut the discharge valve. As the speed increases, the required torque rises rapidly. So here the torque is proportional to the speed of a centrifugal pump. Torque speed characteristic for a pump. Torque demand curve starts at zero speed, rises roughly with the square of rotational speed. At a rated speed, the torque is highest at the best efficiency point. Alright, the induction motor curve. We are using a squirrel cage induction motor, and locked rotor torque must be greater than the pump's starting torque. Pull-up torque. The torque during acceleration must exceed pump's torque at all intermediate speed. Breakdown torque. Maximum torque before motor stalls. Full load torque is the torque at rated speed. Now coming to the matching criteria. Starting requirement. Motor's starting torque must exceed pump's starting torque with margin. For a centrifugal pump, starting torque is low, so this is usually easy. Acceleration margin. At every speed from 0 to full load, motor torque must exceed pump torque to ensure acceleration. Coming to the rated operation, at a rated speed, motor torque equals pump torque at the dew point, at the duty point. That is basically the intersection which you have earlier seen in the curve. Overload margin, motor breakdown torque should be at least 2 to 2.5 times full load torque to handle the transient load surges. Now the diagram explanation is pump torque speed curve starts low at 0 speed, rises smoothly to a maximum at full speed. In motor, the torque speed curve, high locked rotor torque at 0 speed, dips slightly at pull up torque, peaks at a breakdown torque, and falls to full load torque at near synchronous speed. So what happens is falls to full load torque at the synchronous speed. That is what you're trying to achieve, the synchronous speed. Key points in the diagram. Yeah, motor curve always above pump curve from 0 to operating speed. Acceleration is ensured. Insertion of rated speed is equal to operating point. The intersection of the rated speed is the operating point. Adequate margin between the curves to avoid friction where temperature rise. Shipboard consideration. Voltage drop on a ship supply can reduce motor torque, must be accounted for. DOL starting is common for such pumps. Motors must handle such inrush current and torque demand without tripping. Continuous rating. S1 duty is used as main circulating pump runs continuously. Environmental derating like the marine humidity, temperature and vibrations. Alright. So in this question, you have to divide it in such a way. First of all, 2 marks for the introduction. That is, you need to define a pump motor matching concept. What does it mean? Second is the pump characteristic. Talk a bit about HQ curve, torque speed nature. Motor characteristic, again talk about the torque speed curve. Matching principles. What is starting, acceleration, rated, overload, and a diagram that I had shown you earlier. Overlay of pump torque and motor torque curves. Shipboard consideration. What all will you consider during voltage drop, continuous on duty? So those factors. Now question number 2. Explain the term power factor correction. Part B is state the advantages of power factor correction. C is explain with aid of circuit diagram how power factor correction can be effective using capacitors in a 3-phase circuit. D is state one method other than use of capacitor by which the power factor correction can be effected. Power factor is the ratio of the real power by the apparent power, that is kilowatt divided by kVA, as we all know. So the real power which is actually impacting is the kilowatt, and what is the kVA? That is the apparent power. So the ratio ideally should be 1. For purest resistive load, if the load is all resistive, then the power factor is 1, meaning all the supplied power is converted into useful work. In ship, most of the loads are inductive, like the motors, transformers, causing current to lag voltage. So the current will definitely lag the voltage. In low power factor effects, higher currents for the same real power, increased copper losses, that is I square R loss, large alternators, transformers and cables required. Power factor correction means improving the power factor, ideally close to unity, by supplying the leading reactive power to cancel the lagging reactive power from inductive load. Right? That is, you need to provide certain capacitors to negate the effect of inductive loads. Principal add devices, usually capacitors or synchronous condensers, that supply leading VARs reducing the total reactive power drawn from the supply. Advantages of power factor corrections: reduce current draw, low cable and busbar heating. So the cable heating, busbar heating can be reduced. Smaller apparent power demand. Alternators and transformers can be sized closer to the real power needs. Lower energy losses, that is I square R losses are less. Improved voltage regulation, uh, reduced voltage drops across the cable. Cost saving, lower running costs and possible avoidance of the power factor penalties from port authorities or shore supply. Increase system capacity, existing generators and switchboards can carry more load. Yes. Power factor corrections used capacitors in three phase. I mean, again, the working principle is capacitor draws a leading current, an inductive load draws a lagging current. So, connecting capacitors in parallel with the load injects leading current. See, it's in parallel, offsetting the lagging reactive power. The net power factor closes to unity. For a three-phase, three-wire system, delta connected capacitors often used when the power factor correction is at motor terminals. Star connected capacitors commonly used when neutral is available. So in our cases, we do not have a neutral, so you use delta connected capacitors. Diagram again, that is three capacitors in delta connection. Calculation concept is if the reactive power needed for correction, the kVAR is QC can be calculated as 2 pi f v square. F being the frequency voltage, phase voltage square times capacitance, right? Another method of power factor correction is use of synchronous condenser. An over excited synchronous motor running on a no mechanical load supplies leading reactive power to the system. Can be adjusted to vary reactive power outputs. Other possible answers are the phase advancers are there, static VAR compensators are also there. Now here, how you need to answer this 16-mark question is the definition of power factor, cause of low power factor, principal correction. 5 marks it will take. At least 4 to 5 advantages of listed to need to be listed clearly. Explanation plus diagram of connectors in three phase will take another 6 marks. Alternative methods, if we can brief it nicely, it will carry another 2 marks. What is soft starting in induction motor? Describe with circuit using thyristor. Use for soft starting. Discuss the advantages and disadvantages. Definition of soft starting. Soft starting is a method of gradual accelerating an induction motor from standstill to full speed by limiting the voltage applied at the start, thereby reducing the starting current and mechanical stresses. Instead of applying full voltage instantly like DOL, the voltage is progressively increased over the set time. It is controlled by electronic devices such as thyristors in each supply. Why soft start is needed? Induction motors, when started DOL, can draw 6 to 8 times full load current, can cause voltage dips on ship's electrical systems. Sudden high torque can cause mechanical shock to coupling, gearbox, and pumps. Soft starting minimizes these effects, protecting both electrical and mechanical systems. Principle of soft starting thyristors. Thyristors are connected in anti-parallel pairs in each phase of AC supply. By controlling the firing angle of the SCR, the RMS voltage applied to the motor is gradually increased from a low value to full voltage. As the voltage increases, the motor torque increases smoothly until full speed is reached. After starting, the thyristors are bypassed by contactors for normal operation to reduce power losses in the SCR. Again, the circuit description: three-phase supply passes through 3 pairs of SCR. Each phase has 2 SCRs in anti-parallel for both half cycles. Triggering circuit will be a microcontroller or a timer control that controls the firing angle of SCR, progressively decreasing the firing delay. Also, the bypass contactors short circuits the SCR after startup to improve the efficiency. Motor connected in usual configuration delta. Right. Advantages: reduce starting current, right? Smooth acceleration, adjustable starting time, lower electrical stresses, reduced inrush current. What are the disadvantages? Reduce starting torque. Your starting torque will be less. You cannot compare it with DOL. Harmonic generations, extra cost complexity, heat dissipation in SCR, not efficient during start. Yes. Now the mark distribution is the first clear meaning and why soft starters are needed will carry 4 marks. Thyristor control voltage ramping will carry another 4 marks. Diagram and explanation 4 marks. Advantages 3 to 4 points 2 marks. Disadvantages 2 to 3 points another 2 marks. Q4 explain the significance of the root mean square value of alternating current or voltage. Define the form factor. RMS value of an alternating AC or a voltage is equivalent steady DC value that would produce the same heating effect in a thyristor as the AC wave. Since AC varies with time, the average value of the full cycle is 0, so we use the RMS to measure its effective magnitude. I mean, the formula would be IRMS square root of 1 by time period integral 0 to t I function of t whole square dt. Similarly will be the VRMS, and example for the sine wave or the IMR. For sine wave it will be I max by root 2, voltage V max by root 2. Why it matters is heating effect is a resistive element. In resistive element depends on I square R. So power is VRMS, IRMS power factor. RMS value are the standard rating of the AC voltage and currents. Form factor definition ratio of the RMS value to the average value of an alternating waveform over one cycle. RMS value divided by average value. RMS value is 0.707 Vmax. Average value is 0.637 times Vmax. So the ratio of RMS by average is 1.11. Significance of form factor indicates waveform shapes useful for distinguishing between sine waves, square waves, triangular waves, etc. In AC measurement, deviation from the sine wave form factor can sign waveform distortion. What is back EMF? Describe the relation for the back EMF and the supplied voltage in terms of armature resistance. What is back EMF? In DC motor, when armature conductors rotate in the magnetic field, they cut flux and an EMF is inducted. That is Faraday's law. By Lenz's law, the induced EMF opposes the cause which is producing it. So it is called the back EMF. Right? Like back EMF it bonds by 68 P phi Zn divided by 60A. 1 by 60A. P is number of poles, phi is the flux per pole, Weber, Z is total armature conductors, A is the parallel paths, N is the RPM, and omega will be 2 pi n by 60, that is radians per second. Relation between the back EMF supply voltage and armature resistance, V is equal to EB plus IARA, correct? Explain the cargo hold fire detection system on ship. Discuss the maintenance procedures for this system and outline the steps taken when a fire is detected in the cargo hold. Cargo hold fire detection system, again the purpose, early detection of the fire in cargo spaces to allow timely action and prevent spread, especially important on ships carrying bulk cargo containers or combustible material when holds are normally unattended. Fire detection system in cargo hold, like smoke detection systems are there, sampling smoke detection, a network of sampling pipes run through each hold. Continuously operating supply fan draws air from each hold in a sequence to a central smoke detector unit on the bridge or the fire control station. Sequential sampling is controlled by a timer operated valve unit. Detectors can be ionization type or photoelectric type. Advantages: can detect slow smoldering fires easily, less affected by hold access conditions. Coming to the heat detection, thermal sensing cables or fixed temperature sensors mounted overhead in holds operate when a set temperature is exceeded or when there is a rapid temperature rise. Less common for cargo holds with large air volumes. CO2 gas sampling systems, also known as a continuous gas analysis. Air from each hold is sampled from CO2 concentration. Fires produce CO2, so increase above background indicates combustion. often combined with smoke sampling. Typical arrangement for smoke detection type: sampling points, pipe network, manifold with selector valves, smoke detectors, alarm panels, alarm on bridge, and in engine control room. Maintenance procedures: daily, weekly, ensure alarm panel is powered, indicators normal, check fan operation for smoke sampling system, confirm sampling sequences changeover in functioning. Monthly checks: check alarm using the test smoke or the smoke test points. Check suction at sampling point to ensure no blockages. Verify all indicators, lamps, sounders, and control circuits. Quarterly, 6 monthly, calibrate the detectors as per maker's instruction. Inspect pipework for leaks, corrosion, or blockages. Check for air leaks into sampling system which can dilute samples. Annual complete functional test with all holes. Replace any defective sensors, filters, or fans. General note: keep record of PMS. Always isolate system carefully before maintenance to prevent false alarms. Steps when fire is detected in cargo hold: confirm alarm, cross check using secondary indicators, switch sampling manually to suspect hold for verification. Raise alarms, inform master, bridge team, engine room. Sound general alarm if fire is confirmed. Isolate the hold. Stop the cargo hold ventilation. Close all access hatches. Watertight doors to starve fire of oxygen. Fire suppression. Again, activate CO2 system for the hold. Evacuate personnel. Release required quantity of CO2 into the hold. Ensure boundary cooling from outside. Monitor. Continue sampling air from the hold to check the fire status. Keep hold sealed for required time to ensure fire is fully extinguished. Post fire action: ventilate the hold only when safe and authorized. Investigate cause and record the incident. Now, this question: system and working, 6 marks. Maintenance and procedure, 4 steps on fire detection is again 6 marks. Question number 8: discuss the following with respect to international safety management. Management review and its agenda. B. Functional requirement and objectives of code. Master's responsibility and authority. Certification and periodical verification. Right. Management review and its agenda: a formal periodic evaluation of top management of the safety management system to ensure it is suitable, adequate, and effective. Purpose: ensure SMS continues to be met ISM code requirement, identify opportunities for improvement, confirm corrective and preventive actions are effective. Typical agenda are results of internal audit and external audit, non-conformities, accidents, hazardous occurrences. KPIs: feedback from the ship, follow up from the previous management review, changes in regulations or company policies affecting SMS, resource requirement, emergency preparedness test results, recommendations for improvement. Frequency: at least annually. Many companies do it every 6 to 12 months. Functional requirement and objectives of the code is ensures safety at sea, prevent human injury or loss of life, avoid damage to the environment, especially the marine environment and to property. Functional requirement of SMS: safety, environment protection policy, instruction and procedure to ensure safe operation and environmental protection. Define levels of authority and lines of communication between ship and shore. Procedures for reporting accidents and non-conformities. Procedures to prepare for and respond to the emergency situations. Procedures for internal audit and management review. Master's responsibility and authority is implement the safety and environmental protection policy, motivate the crew, issue orders and instructions, verify the specified requirements are observed, review the SMS and report the deficiency to the shore management. Overriding authority: master has the overriding authority to make decisions and take necessary actions for safety and environmental protection, including deviation from instruction if necessary. Certification and periodical verification: document of compliance issued to the company by the flag state or the recognized organization, valid for 5 years, subject to annual verification. Safety management certificate issued to each ship after verifying that the SMS on board complies with ISM and complies with the DOC, valid for 5 years, subject to intermediate verification between the second and the third year. Periodical verification: again the annual DOC, verify company's continued compliance. Intermediate SMC audit between second third year of validity. renewal audit before expiry of DOC SMC, full verification similar to the initial certification. Additional audit may be conducted after a major non-conformity or changes in the management. Now here the management review definition takes 4 marks, functional requirements and objectives again 4 marks, master's responsibility and authority 4 marks, certification and verification will take another 4 marks. Question number 9, with reference to the free fall lifeboat of a ocean going ship, a periodical maintenance tests checks of lifeboats and releasing gears, secondary means of lowering, lifeboat drills, etc. Weekly checks check the engine starting system, check fuel lubricating oil, cooling water levels, check air bottles for inflation pressure, check all survival equipments as per SOLAS inventory, verify securing arrangements, check communication equipments and lights. Monthly, visually inspect hull, canopy, seatbelts, hatches for damages or corrosion. Operate release gears to ensure smooth functioning. Test onload, offload, release mechanism as per manufacturer instruction. Test engine running in the water if possible. Check sprinkler, drencher system and fire extinguishers. Annually inspect release hooks, hinges and securing arrangements for wear. Conduct operational tests of release mechanism by lowering lifeboat to water and launching. Inspect lifeboat structures internally, externally for damage. Test free fall release under supervision if required by flag or class. The secondary means of lowering required by SOLAS for free fall lifeboat usually consists of secondary winch, wire system connected to the lifeboat forward lifting hook. Purpose: lower lifeboat into the water in a controlled manner. If free fall launch is unsafe, maintenance of drill requires slow lowering, operating manual or electrical form within the lifeboat or from a deck must be able to safely lower a fully loaded lifeboat to waterline. Lifeboat drills, again, as per SOLAS Chapter 3, frequency: every crew member must participate in at least one abundance drill every month. Each lifeboat must be launched and maneuvered in water at least once every 3 months, unless impracticable. Free fall in port, then simulated drills are done. Drill procedures for free fall lifeboat: muster crew at the lifeboat station, don life jackets, immersion suits, board lifeboat in an orderly manner, fasten the seat belts, close the hatches and secure it, carry out simulated release or use of secondary lowering means, operate engine briefly and test steering, demonstrate communication and search and rescue equipment, debrief and record the drill in the logbook. Annual requirement: at least one actual free fall launch during drill for each free fall lifeboat on board. Periodical maintenance: weekly, monthly, annual checks will carry 6 marks. Secondary lower the purpose, arrangement and operation, another 5 marks. Drills, frequency, procedures, SOLAS requirement will carry a 5 mark. I hope this has covered all the theoretical questions that have been asked in the paper, and do like and subscribe to the channel. Also share with your friends who are giving the ETO exams, and do drop in your comments with some questions and suggestions so that we can improve upon our efforts to make this useful for all the electrical officers who are giving their exams, and getting helping them to get their COC at the least possible time. Thank you.